All right, kids, so here we go. We're going to take a look at our Algebra 1 Unit 5 review sheet. So here we go. First question, what's the solution to the system equations? What we have to do here is look for the point of intersection, right? And that looks like we went to the point, let me erase that, sorry, there it is. See, 1, 2, 3, 4, 5. So x is 5, and then 1, 2, y is negative 2, right? That makes sense? If all of them were that easy, that would be great. Okay, so here is sort of the same question, but they didn't give us the graph. So if you look up here, for example, we had the lines, you can see where they cross. Now we have to do a little math. So let's take this first equation, let's divide everything by 2. Okay, and if we do that, divide by 2, divide by 2, divide by 2, we get y equals negative x plus 3. If we take this other equation and we want to get y alone so we can graph it, right? So minus x, y equals negative x plus 3. You should notice is these two equations are the same. Means if you graph them, go up to 3. The blue line will go down 1 over 1, down 1 over 1, and so forth. And then the red line, this one over here on the left, would be the same thing. So these lines are on top of each other all the time, which means we have infinite solutions. That makes sense? Okay. Good. Let's go to the next one. Solve each system graphically. So the first one, y equals 3. That's speed jump. Sorry about that. That's easy to graph. We go up 3 and go straight across. That's y equals 3. Put arrows on the end. Don't forget the label.
We need to go left because that's the y and the...
Yeah, exactly. So give y equals are always horizontal. X equals are always vertical. Here I would divide everything by 3. I get y equals x plus 4. So we would start at 4. I'm going to graph this line in blue. Start at 4 on the y-axis. And the slope here is like 1 over 1. So up 1 over 1, up 1 over 1. That or down 1, back 1. And as soon as they cross, you pretty much can stop graphing the lines at that point because once they cross, you have your solution, right? So it's right here. And that looks like the point negative 1, comma 3. Right? Let's take a look at this one over here. So I'm going to solve this by dividing everything by 3. I'll get y equals 2/3 x plus 2. Up here, this one's a little bit trickier. So I would probably do the following. Minus 4x. I feel like most people would do that. Negative 6y equals negative 4x plus 12, right? Divide by negative 6, divide by negative 6, and divide by negative 6. Okay, and if we do that correctly, we end up getting what here? Y equals 2/3 x minus 2. Now why 2/3? Because, let me highlight this, right? Negative 4 divided by negative 6 reduces to 2/3. Okay, so if I graph both of these lines now, look what happens. So the first line, this one here, we'll do it in green. This one starts at 2 and goes up 2 over 3. 2 over 3. 4, down 2, back 3, down 2, back 3. And you get that equation, y equals 2/3 x plus 2. The other one, this one in red, is going to start at negative 2. And that's also going to go up 2 over 3, up 2 over 3. Down 2, back 3, down 2, back 3. And I think, Anthony, you notice what you say about these lines?
Parallel.
They're parallel. So that means they're never going to cross.
No solution.
No solution. That's right. That's what that is. Okay. Let's take a look at the next one. At what point do these lines intersect? So since this is a multiple choice question, if you wanted to, you could try and like plug in every point to both the set of equations and see what works. Okay, that's up to you. Or you could just solve the system. So watch, y equals x minus 8 and y equals negative 3x plus 16. So what I'm going to do is I'm going to take this thing here and put it into that y. because it's substitution. Because
Substitution, yeah.
yep. So you get negative 3x plus 16 equals x minus 8 minus x, negative 4x plus 16 equals negative 8 minus 16, and then you get negative 4x equals negative 24, divided by negative 4, divided by negative 4, and x equals positive 6. There's only one pair where x equals positive 6, so you even need to figure out why. If you wanted to, though, you could take positive 6 and put it in one of the equations, y equals 6 minus 8, y equals negative 2. So it works. Okay. This little challenge here is not necessary for the test. They're giving us one line. Part A says write a second equation, so that's one solution. As long as the lines aren't parallel, you will only have one solution. So pick anything like this. Y equals, for example, 3x plus 5. That line would work. Anything as long as it doesn't have a slope of 1/2. Okay? Let me pause there.
Of course.
They said write it so it has no solution. The second equation has no solution. That would mean that the lines are parallel but don't intersect. So it has to have the same slope, but at different y-intercepts. So let's make it like plus 4. It doesn't really matter. Just as long as it's not the same exact equation. And then the last one says write a second equation so it's implemented solutions. That means you have to have the same line as the line you started with. So if you wrote the same line again, technically that would be right. Sometimes they disguise it. So you multiply this, say I multiply this whole equation by 3, I'm going to get 3y equals 3/2 of x minus 6. And that equation is really the first equation in disguise, which means that the lines lie on top of each other and you have infinitely many solutions.